Hi, everyone. Welcome to our session. We're going to talk about digital twins reimagined, and we'll take a knowledge graph AI approach to it. How cool is that, right? I hear there's a parallel session going on with Andrew and G, and it's amazing to see you guys prioritizing us over that, and will not disappoint you. Yeah. We're coming all the way from New Zealand. At least me and Neil are from New Zealand, and Marco is from the UK. I lead the tribe on AI and data in Spark New Zealand, which is a telecommunications operator over there. Neil is a domain chapter lead in AI and engineering, and Marco is a VP of go-to-market at Relational AI and has been working very closely with us on this digital twin initiative. That picture has a story behind it. Snowflake's founders, Benoit and Thierry, were in New Zealand. I think this year, beginning of the year, New Zealand summer, which is like Jan or Feb, they were there. And the New Zealand Snowflake team took us on a boat trip with them. It was amazing for them to come to New Zealand to meet with customers. And this picture had me on a Snowflake cap, and I thought I'll put that picture in for this introduction. We'll keep it simple today. We'll talk about some innovative stuff that we are doing at Spark New Zealand, because we're trying some very interesting things. We try to be on the edge around AI and creating new things. And then we'll dive into the core thing this session is about, which is digital twin with a will. And Neil will talk more about what does that really mean. I'll not spoil the thunder. Let me get into innovation at Spark and what we have been doing at Spark. Spark is the largest telecommunications operator in New Zealand. We are focused on empowering people in New Zealand using technology, using communications. And in this age of AI, one of the core things that we focus on is how do we take people on the journey with us, right? Because there's all of these discussions around AI taking away jobs. So we are very, very focused on how do we take our employees, upskill them, reskill them, and take them on a journey. And we have this responsibility for not just for Spark, but for all of New Zealand. It's a moderately big company, $3.9 billion of operating revenue, and 2.7 million mobile connections. Now, that might not seem that big in the overall context, but that's more than half the population of New Zealand. So that's quite big in terms of mobile. The AI and data team, we are a centralized team. We're horizontal across the organization. And we not only work on the core data, but we're also responsible for identifying initiatives around AI. We build, and we drive the adoption of artificial intelligence in the company. And adoption is one of the really interesting and important things in the world of AI. We also manage operations, et cetera, around data, AI, automation, assets. Our mission as a tribe is to drive Spark's strategic agenda. We want to be an AI-enabled organization and incorporate AI in everything that our employees do and in all of the journeys our customers experience us through. To do that, we adopt the latest innovations. The field is moving really fast, and we embed AI into the ways of working of our people, but always making sure that we are measuring commercial outcomes as a result of the initiatives that we do. That's very important for us to continue proving that we add value to the organization. Our journey has been very interesting around data and AI. We are agile and really agile because we really accept new technologies. We're early adopters, and we move at pace as an organization. And sometimes when you look back at things, right, it's easier to connect the dots as to how we came to where we are. So our journey, when I look back, started with something we call re-engineering, where there was a consolidation of stack across the organization. Technology stack, CRM, billing, and all of these things. And when I look back at it, that was kind of the starting point for us to get really high-quality data, which has then helped us going forward on this data and AI journey. The next phase of it was deep customer insights. And this phase was about investing into moving data into the cloud. We were one of the first in the region, in the Asia-Pac region, to move into Snowflake fully. And we started putting a lot of time and effort into advanced analytics and AI to understand customers better. But we did that in one particular area of the business, which was marketing or consumer marketing. That was our focus to begin with, to understand customers better. And that was a huge success. As a result of that, we moved into this thing called data-driven operating model, which was, once we have proven our success in one particular part of the business, we wanted to replicate that across all of the other parts of the business. So we moved into network, IoT, channels, into B2B, small and medium enterprises, et cetera. And that's, which is why at this point, right, we've got data products across multiple areas of Spark, data and AI products across multiple areas at Spark. And FY25, our focus is around an AI-enabled Spark, which is accelerating use of generative AI, agentic AI, reasoning models, et cetera. We're playing with multiple different use cases around AI, and the digital twin being one of them. And that's the journey that we are on currently. I'll give you a view about some of the AI products, which spans different parts of the organization. And all of these products are currently generating commercial outcomes for Spark, because we measure that and say, what's the incremental value that these are generating for the organization? The first is Capello. This is a tool that we have for the consumer segment. And this is our precision targeting engine. And we moved away from creating models for each and the predictive models for everything. And rather, this tool is a self-learning tool, which works on a tag-based learning mechanism. And under the hood, it creates the models on its own. Because as customer preferences, et cetera, change, we want to be on top of it and target customers in terms of where they are. We have a tool called Mercury, which is for small and medium enterprises. This is 97% of New Zealand businesses are small and medium enterprises. We've got only a few large organizations. This is, and they are served by these groups called business hubs, which are, there are 26 of them, geographically located across different parts of Spark, parts of New Zealand. Now, this tool is all about, we used to have a contact strategy for our sales team in the SME area, which was about, if a customer provides revenue between X to Y, you contact them once a month, or once in 3 months, or once in 6 months, irrespective of the need. What this tool has done is change that entire business process to say, we should contact customers when they are in market, when they really need us to contact them. So that has enabled us to talk to them more meaningfully about their needs, rather than look at it from an inward perspective. Third is Client HQ, which is a B2B, an enterprise sales tool. When you talk about B2B and you talk about AI, and B2B sales especially, what you'll normally hear is that B2B sales is very person-dependent, relationship-driven. So AI, what role does it have to play in there? So we took a very different lens that instead of recommendations, we provide insights about B2B customers to our sales agents. We create profiles of our customers, we create SWOT profiles, use generative AI for that, and then provide recommendations as a part of that, instead of just saying, sell this product to customers. It has really, really high traction with our B2B sales agents at Spark. And finally, Spark GPT, which is, like every company is creating their own GPTs, right? Most of you will have it as well in your organization, internal employee productivity. But where we are going at is to combine structured and unstructured data and bring it together as part of this tool and enabling a chain of thought. By chain of thought, what I mean is an employee should be able to go into nth level of detail and query something. For example, so we've got a contract assistant, which is part of the tool. Can I ask a question to say, tell me about the Spotify contract, right? It will bring up the Spotify contract. You can engage with the contract and ask a question about it, but you can also say, how many customers are on Spotify with us, right? Spotify is one of the things that we sell as a vast product, and it will go into structured data and get that information from you. If you want to know more about Spotify, it will go to our SharePoint and figure out that information and present it back. So you can kind of follow through a chain of thought, right, that I want to have and follow through in the tool. That's something that we are creating using a routing logic, and very, very proud of that. And
the top.
Oh, wrong button. And a lot of it is powered by the Snowflake AI and Data Cloud. We've got other partners as well, but this session is not about them. So Snowflake powers a lot of the underlying data and security, et cetera, for us. Yeah, so that's about Spark. I want to keep it short and hand over to Neil to take you to the real thing, which is the digital twin and how that has been created. So over to you, Neil.
Thank you very much, Anshuman. Fantastic crowd, at least. And again, thank you for coming in. All right, so we are going to get to the next part of it, which we have named the section as digital twin as well. Now, I will start with this. Consider what if your business had a digital replica, a component that could think about stuff. Now, if you think about it, this system that we are talking about is not just about mirroring what your past looked like or what your operate model looked like at this point in time. A system that can actually think through time and reason on top of it. It can anticipate outcomes. It can decide what to do next. We are really not talking about dashboards anymore. We are not talking about the concept of analytics of what has happened in the past quarter. What we are really talking about here is a system that can actually simulate your what-if scenarios, that can rationalize through your futures, and at certain points in time, it can recommend what your next action might look like as well. And these systems evolve over time, understand patterns of your business, and understands your kind of business deeply. Now, I'll give you an example. Last year, we were in a planning session where we were trying to decide if we should be cutting our roaming cost for our prepaid base or not. And as usual, we had like 6 teams, 10 spreadsheets, and literally no agreement of what needs to be done whatsoever. Now, at that point in time, if I looked at it, like the marketing team went and said, okay, this is going to boost our customer experience. Finance went and said, this is going to tank our gross margin. And it felt like everyone was really guessing about what's going to happen, right? Now, I was sitting in that room and I was just thinking that, how are we making multi-million-dollar decisions? Is this the best way that we make multi-million decisions anymore? Is there a better way for us to really test hypotheses before we actually launch a particular product or take an outcome? And this is what it is about today. It's about building systems that don't just describe the present world where you kind of sit in, but models how decision plays out in the environment, right? Because if you look at telecommunication today, flying blind is extremely, extremely expensive and risky. Now, if I go a bit deeper into telecommunication as a business, telecommunication is not only operationally complex, it's also systemically complex as well. So you can almost imagine it as a stable non-equilibrium state that it kind of lives almost always. So you make small changes to certain parts of the system. For example, I can introduce a new plan, I can run a new promotion, I can try to respond to a network outage, or I can respond to a customer kind of promotion. It almost sends through a ripple effect in terms of what it leads to if you make changes to some of these systems. And a lot of time it's not even like linear. So for example, we can adjust a plan. Adjusting a plan leads to reduction or increase in churn. Increase in churn leads to reduction of your base volume. Reduction of base volume leads to your reduction of gross margin. And if you try to look at this whole sequence of events, they are really interconnected to each other, and you really need to understand this well for you to be able to make sense of it and then take actions on it. And telco as an industry is, of course, getting hit hard in last 10 years in the middle of these operational and systemic complexity, right? I mean, 62% of telecommunication companies actually admit that collaboration and culture has been one of the barrier to adoption of AI and innovation. On the other hand, 2 out of 3 business leaders actually talk about the dissatisfaction of data-driven insights. If you look into last 10 years, I mean, our workforce in telecommunication has gone down by 25%. Our revenue is going down, cost is going up, and as I said, the cost of guessing is extremely, extremely high. And however, then if you look into kind of telco as a business, what I feel is that we need system that is focused more on the foresight than on the hindsight. So if we could have living and breathing model that we can simulate behavior, test consequences, kind of grow, and that grows smarter every day, it would be really, really important. And to me, I kind of look at it like this, that we have lived in this world where we have lived in a world of system of records. If we can get to a system of reasons, that would be a fantastic direction that we can take forward. Now, I talked about living in the foresight and not in the hindsight, and you don't have to go anywhere else than look at digital twin as a construct. And if you look at digital twins are just live computational model of a system. And a system can be anything. It can be a process. It can be a natural phenomenon. It can be a city. It can even be a human. And there are many examples of digital twins around the world. If you kind of take a look at it and search Google, do your deep research, you will get to a lot of digital twins around the world. A great example is one of our New Zealand companies, Soul Machines, who are kind of building and replicating digital twin of emotional intelligence. It tries to simulate real empathy and emotions on machines in response to human sensory stimuli. So it behaves very similarly to the way we actually react in the world, in machines. On the other hand, you kind of look into NVIDIA. NVIDIA has introduced Earth 2 in 2024, and the goal is really simple. It is to solve our current and future climate and kind of weather-related problems by analyzing and simulating weather events. On the other hand, if you look into Singapore and New York, they have been building their digital twin of their city, and they actually use it for many different purposes. So they actually use it for traffic management, for urban planning, for energy understanding energy consumption, and so on and so forth. But what really makes it powerful is not the fidelity of this model. I think the power comes from the ability to run real experiment with almost zero cost whatsoever. So you can rehearse many times different possibilities, test hypotheses without actually incurring the cost. It almost kind of becomes a sandbox for decision making, if you kind of think about it. Now, the other bit that's happening, so we have talked about kind of digital twins, and we have talked about processes and kind of systems that you can kind of develop. Now we are at an era we can even build digital twins of humans, and everyone knows how many kind of people know about agents? Everyone probably, right? An agent is a construct that has become really popular in the last 1 year in LinkedIn, but it's not really a new construct or concept. It has actually existed forever. But this allows us to almost mimic or templatized goal-driven human behavior into machines. So if you take an example, I have taken an example of myself, that's Neil. I can almost templatize myself in this world where I have kind of certain goals in life. So my goal in life is to kind of bring AI adoption at Spark. Right now, my goal in life is to kind of tell you that agentic AI is real, and so on and so forth. I also have a strong operate model that allows me to engage and interact with the world with certain principles, right? So kind of, for example, you can kind of think of, I love to listen deeply and engage with other people. That's the operate model that I operate in the world. I kind of believe in if I need help, I ask for help, and if someone needs help, I kind of provide them the help. Those are the operate model that I have in the world. I also have knowledge. So I act on this world because of the knowledge that I have gained from my past, that comes from my education kind of background in AI. I kind of go and listen to podcasts. I kind of read Reddit posts and so on and so forth. And I also have certain tools that makes my life easier. So I have certain digital tools, certain physical tools that actually helps me act and react better in this world. Now, If you think of agents, the other bit that's really interesting that you are going to kind of observe is agent at the end of the day, if you look into the kind of cognition of human agent, it's almost a forever loop of research, reason, react, research, reason, react, and you almost kind of iterate on this particular loop. And AI has been growing and it's kind of getting 10x better in all these three aspects. If you look into information retrieval, we have now got into a place where merging structured data and unstructured data, merging public information and kind of organizational information is really, really simple. And from that point onwards, we have gone from information retrieval to research at this point in time. Reasoning, I don't probably have to kind of elaborate a lot on reasoning. We can see what the GPT models can do nowadays with kind of reasoning. On the other hand, acting in the world are getting easier as well, and almost it's getting proactive as opposed to kind of reactive. Now, let's take a step back and ask, what is an organization really? At its core, if you look at it, it's a large optimization system. We almost orchestrate people, process, and tools to reach that objective if you kind of think about it. But rarely this is a single goal. For Spark, for example, we are trying to simultaneously optimize for our EBITDA and our customer experience. Now, while being constrained by our compliances and values and sustainability objectives. So if you fundamentally think about an organization, and again, I love oversimplifying things, fundamentally an organization is a large optimization. It's a constrained multi-objective optimization problem. Now imagine this, if you could represent every function, product, customer, network as the digital twins, and then orchestrate them together towards the shared goal. That's not a dashboard really, that's not just an automation, right? So what you're talking about, it's a digital replica of your organization. Now, let's say we can build a digital replica of our organization, which is a big word to kind of say, to be honest. But if we can build this, if we can describe this, what can we do with it? We can, for example, simulate it. That's how we actually move from describing a system to actually being able to interrogate it. I can go and ask, what happens to Y if I change X? And if you look into this blue box, and if you can imagine that here is a digital twin of an organization that's described by this box, now you can interrogate by asking very interesting questions. What happens to EBITDA if I introduce a new plan in the market? What's the impact of revenue if I have a major network outage? What happens if a new competitor shows up? So now I can start interrogating the system and see how the system reacts, and we can also explain it why it happens. Now, I'm going to switch gears a little bit, and instead of staying really conceptual, I'm going to run through a simple example of how you would actually build a simulator, step-by-step process of building a simulator. And it's oversimplified on purpose just to make the thinking more concrete. Now, to simulate anything, you first need to define what you are simulating. In telecommunication, for example, you can get started with almost two entities, customer and revenue. And we represent each of these entities by structured data, even unstructured if you want to at some point in time, in its simplest form. These are just attributes that describe your system. For customers, it might be, I don't know, the demographic information, it might be the likelihood to churn, it might be what products that they're getting, and so on and so forth. Those are the data points. Similarly, if I look into kind of revenue, I can kind of more or less think of tracking them by product, by location, by region, by channel, and so on and so forth. So those are the entities that you go and define. And this step actually makes the concept of business represented in the model. And there is no surprises over there. We have actually been there, done that. But this is where it starts getting really, really interesting. And now, step two is that I can now start forming relationships. For example, if you take the entities that you have, you can think of customers and revenue. We can connect them together. Let's start with the obvious one, right? Customers generates revenue. And this is a direct causal relationship that we are talking about. If a customer upgrades or downgrades their plan, their revenue goes up and down. As a result, it's a causal relationship. And these are the kind of relationships simulators needs to model so that we can later ask this question around the kind of what ifs. And relationship is a very, very, very important part of that particular system. However, not all relationship works the same way. I'll give you a few examples. There are certain relationships that are descriptive in nature. For example, this customer is on a postpaid plan. This is a very factual thing that we are talking about, which is just descriptive. Then you can think of correlational kind of relation. Customers who contact the call center are more likely to churn. There is obviously a pattern in there, but that's not necessarily the cause. So it's very correlational in nature. It's definitely better to represent them in the information, but that's not your final destiny. But then you can also have causal relationship, right? So billing issues leads to churn. That's surely a causal relation. And we want to create these links because eventually the simulator has to understand and reason through this for it to kind of get to the outcome. And here's the powerful bit that happens as you start representing these relationships. The moment we start now identifying and classifying these relationships, we are no longer dealing with disparate data points anymore. We are now starting to create knowledge. Now, relations are one component that actually transforms disconnect facts into structured understanding, and that's the foundation towards your reasoning, and I'll come to that. Now, if we can now represent relationship, and now we have entities and relationship, like customers and revenues, now there's the new construct that you can add on to it, which is semantics, which is really, really interesting. Now, semantics are just business rules that defines how systems behave. Not just who belongs to what, but what is allowed, what are the constraints. And I'll give you an example. So if you think of this particular graphic, a customer belongs to a household. That's obviously a relationship, right? A customer has a music bundle. Again, that's obviously a factual relationship. Now, here's a rule. Only one music bundle is allowed per household. What you'll realize is that these kind of rules are often not represented directly in your data stores. Of course, from the data, you can go ahead and dig enough for you to be able to infer those relationships, but they are not directly represented in the relationship. Often, these rules are either unwritten, sits in some policy documents, or even worse, sits in someone's head. Yeah? Now, if you can explicitly write these relationships in the system and represent them, you again start to capture knowledge and you start expanding what it can do. Cool. Now we have entity relationships and rules. We don't stop there, is it? If we can represent that, and now we are going to observe it, how it changes over time, right? And if we now start looking at it, tracking at it in terms of how it evolves over time, customers, of course, comes and goes, revenue fluctuates, rules gets triggered, and this temporal view is extremely essential because business is really dynamic, reactive, and it's constantly changing. Now, capturing these changes of time sets up for the next step, which is the most important part, which is reasoning. Now, of course, we have got entities, relationship, rules, and we can track changes over time. Of course, now we can hook up this reasoning engine on top of it. Now, the reasoning engine takes all these historic data patterns, rules, entity sets, and learns how the system behaves. Now, it just does not apply relationship, and here's the interesting part. It starts discovering new relationship. So, for example, when it observes customer churns right after the contact kind of center calls, it can almost infer a relationship that there might be a call-related issue that came up or a billing-related issue that was there. So it's now starting to figure out those relationships. And this is what makes simulations powerful. It just almost starts thinking with you. Now let's say we have built a simulator. What do we do with it? And I kind of talked about it earlier. And now you can kind of think of, if I have a simulator, I can now start asking what if questions. What if we added 20% more young people to our base? What if travelers stop purchasing a SIM? Now, the reasoning engine actually takes all these hypotheses and runs them through a simulator, which maps through all the ripples and kind of progression across the system, and we get an outcome, like the potential impact on EBITDA or churn, and we can reason through it now. Now, of course, it's a clever bunch over here. I don't need to expand on this a lot. You can already realize is more connection that you create, you get to a richer decision. And understanding system behavior through more connected data is really, really important. Because if you really think about it, real-world outcomes are shaped by a lot of interconnected factors. So if I look into why a customer churns, it's not just one factor that describes it. That might be their kind of experience with the product, the pricing of our product, what our competitors are offering, and so on and so forth. So it is extremely important for us to be able to represent that. And as we add more entities and relationships, it helps simulate simulator better reflect those complexity, which is important. And it makes it easier not to explore the what in terms of what changed. Now we can go and explain why it has changed because I can see through those relationships and understand the causal effect. So more relationship leads you towards causality as opposed to just what has happened. And of course, you can start asking now better questions and get more interesting answer as you start doing these things. Now, finally, if you think of optimization, optimization is almost the next step after simulation, which is a step towards autonomy. So you almost ask the question in a different way. When you are simulating, you are asking, what happened if I change something, right? That's what you are asking. But if you go to the optimization, what should I change to get the best result? It's turning the question around. And if you look into kind of system, if we can simulate, now we can optimize as well. It's at the end of the day, it's just a search on top of your simulation. If you kind of think about it, and again, I'm probably oversimplifying it, but optimization is a natural progression from kind of simulation. And you can ask, so I've provided a lot of examples on that. I'm not going to go through a lot of them, but one or two would be like, for example, in marketing, you can go and say, what's the best channel mix to boost revenue? Right? So revenue is an output that it generates, and your inputs are channels, and you see how it gets impacted. You can also go and add constraints to it. For example, you can go and ask that, like given a fixed budget and headcount, what's the best mix of action that I can get to reach our target? So where you can add constraints to the system for you to be able to answer it. All right. I'll hand over to Marco. Now talk about relational AI as a platform and how it's helping us achieve our dream.
Thank you, Neil. Hi, everyone. I'm going to pick it up from where Neil actually left. And what I want to do is really two simple things today. Is one, I have a single slide that I hope I'm going to use to justify a key insights that I want you all to take away of this talk that we are doing together. And then I'm going to show a demo, because who doesn't want to see a demo of everything that we're talking here? So if there is a thing that we can take from everything we heard so far is organizations are fairly complex machines, right? And those complex machines needs to make decisions, right? And these decisions comes in all different forms. We talk about simulations, we talk about rules, we talk about knowledge, we talk about optimization, right? Like you have all different types of decisions to make. Now, some decisions are easier than others, and we are lucky. We live in a lucky, in a lucky era here, because the barrier to make decision is becoming easier and easier to everybody, pretty much. Right? Like nowadays, if you want to ask a question to your data, it's like, hey, can you please help me to figure out what my sales were last month? Now there are systems in place like Cortex Agent that takes that question, translate that question into a SQL statement, and you get the answer without knowing actually what's going under the hood. And similarly, if you want to ask a question, hey, can you help me to fix like a piece of equipment, and I know that that information is somewhere in my documentation, now I got like Cortex Search, I can ask that question, I might not know what's doing in the background, but I get the answer, right? And so now this is amazing. But the type of questions, as I say, that organizations need to make is usually a little bit more complex. Organizations need to think about the past, they need to think about the present, they need to think about the future, and they need to think about what to do about it, right? And historically, when BI and AI will fall short, we went into the application mode. So we built applications whenever we couldn't do with AI and we couldn't do with BI. And the insights I want to leave you today is that the world of AI and the world of applications are starting to merge together. Okay, they are overlapping more and more, thanks to some of the advances that are coming to bear for us, for all to use. So let me explain what I mean by that. So all your data pretty much lives already within a centralized system like Snowflake. You got tables, you got your JSON data, you got your documents, you got your graph data, you got your images. It could be that you're also importing some external data, but you have a centralized repository for all your data. What we're saying here is that on top of that, now you have at your disposal already, right, like a set of what I call reasoners. Reasoners are really capabilities for you to help you reason about your data. We talk about a SQL reasoner, so you take a question, you get a SQL statement, and on your tabular data, you get the answer. We talked about search and similarity search. Right, like that's a similarity reasoner. Right, like you ask a question, the question is translated into a RAG system or vector similarity, you get the answer to that question. What relational AI is doing here is adding now a set of reasoners to your Snowflake AI data cloud. And those reasoners are the rule-based reasoners, so the ability to now define complex rules like the one that Neil was describing before, and then let the system compute those for you and figure out what happens when some of those rules are, for instance, invalidated. You got a graph reasoner, so now the ability to run graph algorithms on top of your data and to discover insights, hidden insights on your network. You got a predictive reasoner. That's like through graph neural network. So the ability to ask a question about the future and to have an answer with a high level of accuracy with minimal, if no, feature engineering at all. And then you got a prescriptive reasoner. Right? Like now that's the ability to ask an optimization type of question to your data. Right? Like, hey, can you help me, as Neil was saying, to figure out what's the optimal marketing mix to maximize revenue but minimizing churn. That's an optimization type of questions. And what we think it's interesting, though, is that usually that's not enough. On top of that, you have what we call a semantic layer, right? Like, so why would you let both humans or machines to try to figure out what the data means? Human struggles. Machine, I would say they also struggle. So what we have learned is like it's way, way better to provide humans and machines with a domain of the word in which they need to provide an answer to, okay? And there are two words here there are two ways, let's say, in which you could do that. There is a dimensional type of semantics that are usually used for BI type of analytics. So these are like the type of things that enable you to, slice and dice the past, right? Like, and these are like, these two methods are really complementary one to the other. But then when you need to build applications and complex applications, usually BI semantics are not enough, or dimensional semantics are not enough. You go into the world of knowledge graph. And so knowledge graphs are a way for you to capture complex, behaviors, semantics, concepts, relationships, constraints of your business. And then what's becoming really interesting nowadays is that with the advent of Gen AI, you have a Gen AI reasoners on top of it because people want to interact with the system through, in the majority of cases, natural language. And so now that Gen AI reasoner is actually fine-tuned to the business domain in which it needs to provide answer to. It's a process we call super alignment here. It's basically using a knowledge graph to teach the LLM what it needs to know in order to answer a specific question. And now you let the LLM figure out what is the right reasoner to answer that question. In some cases, it could be a SQL reasoner. In some cases, it could be a predictive reasoner. In some cases, it could be a prescriptive reasoner. So what I'm trying to say here is that we're moving in a world where we are creating really what I call a relational AI unified infrastructure, okay? So, and the reason why I'm making this, a little bit of a cheeky here, play on words and saying relational AI infrastructure, it's because it's an infrastructure that is based on a relational system, right? Like relational systems like Snowflake, and it's providing now the full set of capabilities that you need in order to do complex AI applications, okay? So with that, we will, I would say we will look at the demo. I think that's what everybody probably wants to see. You want to see a demo? Yeah. Okay, that's good. That's good. So what you're going to see, I'm going to start the demo in a moment here. It's the result of a work we're at the very beginning of this partnership, but it's just a few weeks of work of the joint teams together, where we wanted to basically start dipping our toes into some of these concepts here. And the idea here is to create a digital twin of Spark network, specifically of cell towers, and then let users and eventually agents being able to ask questions to that network and figure out what happens if specific outages happen in the network. So each of the circles here represent a cell tower, and the color tells you basically the state of that cell tower, whether the cell tower is has plenty of capacity, which is the green here, whether the cell tower is at some threshold threshold that is defined by the SMEs, that is deemed to be somewhat critical, or whether the cell tower is red state, which means it's full capacity, right? And so, and of course, the radius of the circles tells you like the coverage of that cell tower. Now, what's interesting here is because once you start model this as a knowledge graph and you have the set of reasoners that I described before, now you can start really asking questions. And one of the questions you might want to ask to the network is, hey, what happens, for instance, if a specific cell tower goes down? What's the implication of that? Will the surrounding or neighboring cell towers be able to pick the load? And so what you see here now, a user is basically inserting oh, I think we went back. I'll describe anyway, we'll move quickly. The user is able to actually input a cell tower number, and then that cell tower is going to be basically grayed out. It's going to say, hey, it cannot pick any more users. And then those users will need to be redistributed to the neighboring cell towers. And you can see the impact of the, you can see here, the before and the after that, right? So now you can start asking questions, hey, what if this goes down, or what if that goes down? And of course, well, we're just showing here like the users are all to 0 for that cell tower. Now the neighboring cell tower will need to pick the load. And one of the cell tower that was, you can see here, the gray cell tower is the one that we switched off. And now the neighboring cell tower that was green has become yellow because it's actually reached the critical threshold. That's interesting, of course, but it's not everything, right? Like we can do. We want to do a bit more here. What happens if we actually had to our knowledge graph demographic information? Now, knowledge graphs are amazing because they enable you flexibly and with scale to add information as you wish. So now that we add demographic information, now we can mix these two together and create a simulation. And hey, what happens now if my population distribution changes over time? And see the impact of that. Okay, now what we're doing here, we're basically increasing the number of 15 to 25, if I remember correct, age bucket, and see now the implication that has on the load. Okay, so of course this is just the beginning. You can see a world in which now we're gonna have agents doing these sorts of things. We can see a world in which we're gonna add additional information there and become more and more rich the type of analytics that we can do. But this is the direction of travel here, and so we feel like it's an exciting place to be. It enables really the foundation to build this sort of like a fully fledged digital twin on an organization that then enables all of us to make better decisions. And with that, I'll hand it over back to Neil. He's going to close out.
Be pretty quick. Oh, that's all right. Yeah, pretty quick. So I'll just quickly summarize in terms of what we talked about kind of today. What you could see is kind of today what we went from connected data, which is entities, relationships, semantics, and so on and so forth. We went and built what you call as simulators, which is reasoning through any change that happens. So you kind of perturb certain inputs and you observe what has happened. On top of that, you can also now reason why it has happened. From that point onward, we kind of went into how do you drive optimization, which is how do you change things the right way. Okay. And then we slowly can go towards autonomy, which is how do you improve, like how do you build systems that actually improve themselves and learn. I will probably leave you, every one of you, with this. So we actually have gone from observing reality to modeling it, from modeling it to simulating it, from simulating it to optimizing it, and soon, where we are trying to go is from optimizing it to automating it. That's about it. Thank you very much.